Why suka? Fresh. What is this? Oh my soul. You guys, so much drama. It's like the drama, the intrigue. Too much drama. Too much drama. I mean, tears. I think when in your if all things fail for you, I don't know what you wanna be, what you wanna do in life. But if all things fail, then you know you have drama and acting as a backup. Um, then you can go, you know. Okay, so um, no, guys, it's no joke. It's no joke. I'm not joking because, yeah, like I said, I think if you guys really understand how things will be when things are in full swing and back in school and all of that, then yeah, you'll understand why it is that this then has to be kind of like the last formal session, in the sense that I will not be able to consistently like hold lessons and sessions every single evening, that type of thing. But what we can do obviously is that occasionally, when the occasion permits, in a particular evening, we can converse about and arrange for a specific evening. But like I said, it can't be as consistent as we had it, in the past few days. So that's what I mean. I mean, also, guys, I'll be available, to assist you, whenever and however you need, if you need me to. So you can always shout, holla if there's anything in particular that you need, Yeah. You can always holla. But when I say last session, I'm saying last session in the sense that consistency, everyday session, So I have to put it in that sense. But yeah, hopefully you understand what I mean. And yeah. So guys, this is the work that I had given you to do as a game challenge, And I appreciate those who actually sent me their work. I can see that slowly but surely people are getting into that mood and vibe where when work is given, some of you are able to do it. You send me the pictures of your work. I am able to check it out. I send you feedback. So those who obviously sent will know that feedback was given to them. And so it makes learning and understanding maybe a particular thing then easier, if you know what I mean. Angel, if you are new here, welcome. It's just that you are new at the end. You are new at the end. But welcome. I'm sure everybody else in the comment section, like Co-Precious, has just welcomed you in and stuff. But you are new at the end. We've been at it. We've been at it. So, we'll look at number 7 as per the request. Something that's quite shocking for me is how difficult it seems that some people are even having to do like some, a problem like number 2, for instance. And the funny thing is, it's the factorization that some of you are struggling with. So it's not really the method of solving a third equation that you have a problem with, but it's the factorization. Thank you, Luan. Luan, I didn't know that you are quite the actor. I saw I saw a TikTok video of you playing hide and seek. I think it was with your siblings. It was hilarious. I think you've got the makings of being a, what you might call, is it a producer or something like that? It seems like you've got talent there in the arts. Yeah, I laughed my head off when I saw that. That was quite funny. Anyways, that's Lonely. Lonely is multi-talented, I see. Yeah. So anyway, so I was saying that number 2, I was looking at that and I'm like, guys, some of you, it seems like you're struggling with factorization. So I'm actually going to do number, let's see. Okay, Which ones should I do? 7 is for sure, because I think there was many cases of people that I marked where number 7 was an issue. But I think for the most part, those that I actually marked were able to do most of these problems. So number 7, okay, and I see Cheho is saying number 5 as well. Okay, so I'm going to do 257. 257, if we can agree on that. And there's a reason why I'm actually going to do number 2 as well, because I was shocked about something that I consistently saw when people were working things out. So remember, what did we say is the steps or the method that we take when we are solving a surd equation? There is a surd, and this is an equation. We want to solve it. So basically what we do first and foremost is we look at our equation, and what do? Yes, Queen Sokudela. We isolate the surd. So here we can see that the root here is a representation of that surd. So we have to isolate it. It is already isolated. The surd is isolated. So after isolating the surd, the next step then it would be, I think the comment section is going down very well. So isolation of the surd is the first step. So here the surd is already isolated. Given then says we square, and Presh extends it by saying then we square both sides. So let's go and square both sides. The function of squaring both sides is so that we can remove the square root. The square root has been removed. But what we do on the left, we do on the right. So x squared here, the x squared term is already positive. So we are going to transpose x so that it joins the x squared. So if you think about it, we have x squared minus x. Okay? Right. So that is called standard form. So step 1, isolate the surd. Step 2, square both sides. Step 3, standard form. Standard form. Iso, square, standard form. Then after that we factorize. And this is the part that was really shocking for me. I saw people opening 2 brackets and say x minus x into x minus x. Okay, which was a clear indication to me that factorization is a problem. So obviously here we have x squared minus x. There's a highest common factor. The highest common factor is x. And it's always the base that has the lowest exponent. If we have common bases, it's always we take out the base that has the lowest exponent. So we can say therefore x squared minus x is equal to 0. When we factorize it, it's x on the outside, and then what's left inside? X minus 1. Are you with me? Then we have x is equal to 0 or x is equal to 1. So after standard form, we factorize, then we apply that 0 factor law which leads us to the roots. Okay, and then the last step is we must check. Okay, and I was explaining to one of the learners who had sent me their work that it is not necessary for you to basically check and go and rewrite this thing. No, all you need to do is just take the values and go plug them back in the original equation. And you can do that mentally, or you can do that using your calculator, so that you can simply conclude about the roots that qualify as your answer. So if you take 0 and you substitute it here, the square root of 0 is 0. So you have 0 on the left, which is equal to 0 on the right if we substitute it. So 0, it qualifies. Take 1. X is equal to 1. We also substitute it. The square root of 1 gives us 1. If we take that 1, we substitute it in the place of x, we also get 1. So 1 is equal to 1. So x is equal to 1 also works. So both roots are fine. So here, when we checked the answer, both of the roots, they are perfectly intact because they satisfy the equation. So please, people, let us make sure to check, so that in the situation where maybe one of the roots does not qualify, we indicate it. But in this case, both of the roots are perfectly fine. So we leave the answer as x is equal to 0 or x is equal to 1. Together? Amen. Let's move on to 5, which was the next one that you wanted us to do. 5. 2 into root 3 minus x equal to x plus 4. Once again, step number 1. Step number 1 says we isolate the surd. So currently, as we see it, the surd is isolated. It's just that 2 is a coefficient to the surd. So this 2 still means this is one term. Remember, this isolation just means that the surd must be a single term. That's what we mean by isolating, single, alone, alone. So this 2 is multiplied to the surd. So it's one term. So this is an isolated surd. So what we do then is that since we acknowledge this is an isolated surd, then it means we can go on to the next step, which is to do what? The next step is to do what? After isolating the surd, and we can see that the surd is isolated, step number 2 is I know you are saying it, we square both sides. Thank you very much, Shizrati. Can always trust in Shizrati. But what we do on the left, we must do on the sweet, amazing right. Remember, when you apply the square, we apply it both to the coefficient and the square root. When you apply it to the coefficient, which is 2, we get 4. When you apply it to the 3 minus x, remember, we get 3 minus x. But let's please make sure we still have brackets intact, because this 4 needs to eventually be distributed to the binomial. Monomial by a binomial 3 minus x. Okay. Then on the other side, x plus 4, the whole thing squared. It means we have 2 brackets of x plus 4 that obviously we know that we open. Okay. And I'm going to shortcut this process. 4 times 3 is 12. 4 times negative x is negative 4x. Got it? Amen. FOIL. X times x, x squared, x times 4 plus 4x, 4 times x plus another 4x, 4 times 4 is 16. Okay? FOIL, FOIL, FOIL. Okay? This is grade 11, Pumzile Buteles. Okay? Then we need to get the equation into standard form. Already our x squared on this side is positive, so we're just going to transpose everything else on the left. That negative 4x, when it crosses over, it becomes positive 4x. We have a 16. We take the 12 over, it becomes minus 12. I'm sure you get the point, guys, with the 0. Therefore, okay, let's simplify so that we get standard form properly. X squared, 4x plus 4x plus 4x gives us 12x. 16 minus 12 plus 4 equal to what? 0. That is our standard form. 16 minus 12 gives us 4 as our constant term. Now, when you look at this, you can factorize it as much as you want. It's not going to happen because the factors of 4, where you have the same signs in the bracket that are positive, factors of 4 can never be able to add up and give you 12. So that means we cannot factorize using the factorization method. The next thing that's there, that we may think is, maybe we can use the solve for x by completing the square. But guys, we haven't been told to solve for x by completing the square method in the question itself. So we don't even go there. So the next big beautiful thing to use is to use that formula that we love and know, which is called the quadratic formula. Beautiful quadratic formula. Equation is already in standard form, so all we do is we identify a is equal to 1, the coefficient of x squared, b is equal to 12, the coefficient of b of the second term, the x term, and c is equal to 4. And then we just substitute in the formula using brackets. Minus, b is 12 in brackets, plus minus, square root, b squared, 12 in brackets, squared, minus 4. A is 1. C is 4. Okay, all I've just done here, guys, is I've used this quadratic formula, identified the coefficient of x squared, which is a, the coefficient of x, which is b, the coefficient of c, which is 4, substituted it into this formula. In the place of b, I substitute 12. There it is. But I use brackets to substitute. Very important. b squared. In the place of b, I substitute 12 with the square on the outside, of course in brackets, minus 4. In the place of a, we substitute 1 in brackets. In the place of c, we substitute 4 in brackets. Mr. brackets 4. Okay. Over 2 brackets 1. Given my givovo, you said Mr. and then you have brackets 4. Were you just saying I must close that bracket at the end, or what exactly were you saying to me? Me? I'll allow you to. Okay. Then I said there's this part that I need us to always reveal in our working. Alright, and this is this part, and then the single value outside, also what we get for the square root inside, because usually sometimes there's a mark in there. Okay, so that's the 12 4 squared minus that's 16, we get 128 here. Okay, right, and then here we can use our calculator and get the values. Okay, let's punch it in. So when we go to the calculator, we punch it in just that fraction. Okay, no problem. In that calculator, we make sure we choose the fraction form. At the top, we have minus 12. We put plus first just to accommodate the plus answer. We know we have two answers. There's the plus answer and the negative. 1 for that. And then over what? Over 2. We press equal. We get the third form first. Okay, they didn't say leave the answer in third form, so we then assume that. Remember, if they wanted you to leave the answer in third form, they will state it in the actual statement of the question and say, solve for x, leave your answer in simplified third form. Okay, but if they haven't said so, then it's our prerogative to basically round off that particular answer to 2 decimal places. So we can write the initial third form answer if we want, and then of course finally we have minus 0.3 and it's 3 4. Or let's go change that plus there in the middle to change it to minus so that we can see what our second answer is. Delete, put minus inside. There it is. Okay. Let's press the ST so that you can get the decimal. It's negative 11.65. And remember, after the 5, we have a 6. So the 6 says to the 5, round up. Okay, remember, if this number is 5 and more, it says go up to the previous number. But if this number was 4 and below, then obviously we would have this number stay the same. So our answer is negative 11.66. That's the second root. And voila guys, voila. Okay, let's look at the very last one, the one that you guys love and know. Look at this question, so beautiful, right? Square root of 2x minus 1 minus square root of x minus 1. Number 5 gave you a hard time yesterday. Do you see how actually not so hard it actually is, in that when we get to the standard form, unable to factorize? Remember, we said, when we were doing the quadratic formula in previous sessions, we said that you always use the quadratic formula to basically solve for x. And I really love the fact that people in the comment section are now commenting about something that I should have done. And remember, this thing has to be done. We check. Precious, you are the woman. Unwa Masaseka, thank you so much for joining. I hope you are well, and I hope you are taking care of yourself. Precious is the one. I forgot to check. Did you see how smooth, how easily I shifted from the solution, and I just went to the next thing? You see? And I forgot to do the last thing, which is to check my values. Okay? So let's check it, bruh. Let's check these values. Let's go back, okay, and check these values there, just to see if they are actually going to satisfy the equation. So we have 2, we have the root, we have 3 minus x. Okay, so that means basically 2 root. Let's just take one of the because it's 2 minus, and obviously in the bracket there we're going to have minus minus. So let's take the 11,6 first, 11,66, and just say equal. I'm sure you guys saw what happened there. Okay, 3 minus minus, because I'm supposed to say 3 plus inside the square root. Okay, I don't want to have a negative number, so if it's gonna be 3 minus minus 11,6, that means 3 plus 11,66 inside the bracket. Now, what is the square root of that answer? And then if we times it by 2, what do we get? We get 7,65. That's if we substitute negative 11,66. Now, if we take that negative 11,66, we see what we see on the left, 7,66. Let's see what we can get if we take that negative 11,66. Negative 11,66, we subtract the 4, or we add the 4. You see, negative 11,66 will satisfy the equation. So this one works. This one works. Let's check negative 0,34. If we do the same thing with negative 0,34, 3 minus minus 0,34. 3 minus minus 0,34. Okay, so that means 3 plus 0,34, which is that we take the 3 plus 0,4, 0,34 first and foremost. That's what we get inside the square root. You take the answer of what's inside the square root, and then you times that by 2. What do we get for the left hand side? We get 3,65. Okay, 3,65, which is 3,66 if we round it off. Do the same thing with 4. We subtract that 0,4 minus 0,34 at the left. 4 minus 0,34. We get 3,66. Guys, both of these values, they work. Both of them. They both work. Both of these values, when you substitute them back into the original equation, they work out nicely. None of them is rejected. Both of them, they satisfy the equation. Now, how's about that? Okay, so we need to always check, because there's cases where both work, there's cases where one doesn't work, and we need to always be checking that for verification. Okay, so both of these roots, they actually work out when we substitute them back into the original equation. Okay, let's go and move on and finish up with this one that everybody has been crying about. I actually had a few learners that actually sent me their work where I saw those other learners they were able to get the marks. Okay, back here. Okay, let's just do it practically. Remember, the first value was negative 11,66 that we had to substitute here. You say 2, you write the square root. There it is, 2 square root. Then you follow that by what? Inside the square root, 3. Now, you're going to have a minus, but then your value is also minus. Minus times a minus will give you a positive. So in other words, you are saying 3 plus 11,66. Let's agree on that. You say equal to, this is the value that you get, 7,657. Okay, in other words, this is 7,66 if you round it off to 2 decimal places on the left. So on the left, we have 7,66. Take note of that. Now let's take that same negative 11,66 and add it to 4. Negative 11,66, we add that to 4. What do we get? We get a negative 7,66. Okay. Oh, this side we get a negative 0.66. I didn't see that. Ooh. Guys, did you see that? So one of the answers doesn't make it. What an error from my side. Big one. Guys, did you see that error that I made? Presh, look at you. Exactly. You are spot. Okay. So if we substitute negative 11,66, it doesn't work. One side we have 7,66, which is positive on the left. On the right side we have negative 7,66. So it doesn't work. Presh, look at you. Man, I feel like, what is this? I think like what it's one of those situations where the master is being superseded by the students. The students are becoming the masters. You see, that's why it's time for me to actually disengage from this situation. Do you see now, Presh? I hope you are getting a revelation of why it's so important for us to stop this situation. I'm so proud of you. You know, I'm so proud of you. I'm so proud of you. Okay, negative 0,34. Negative 0,34. Let's take negative 0,34 and do the same thing. So we have, so we've proved that x cannot be negative 11,66. Thank you, Presh. Let's take negative 0,34 and verify if that one qualifies for satisfying the equation. So we do the same thing. 2, we put the root, we put 3, now minus, remember 3 minus is the 0,4 means we're gonna get 3 plus 0,34. Then we say equal, we press SD, we've got 3,655, right? Which is basically, if we round it off, is 3,66. So on the left we have 3,66. Let's check the right. We take the same negative 0,34, we substitute it on the right. It means negative 0,34 we're going to add to 4. Let's do that. Negative 0,34, we're going to add that to 4. And then we're going to get an answer of 3,66. So even on the right side, we get 3,66. Those are equal. Exactly given. If I leave, you will ask Presh. I think Presh needs to actually set up hell and your TikTok account, Presh. You need to set it up now. I think it's time for you, for me to do. I will do the official handover ceremony at the end of this session, okay? So that we can give over the powers that be to Presh. Ow, my daughter. Wow, Presh. Wow. Okay. And Presh has the number of followers to go ahead and do live sessions. So, Presh, you will officially be the new inducted mem that will push us forward, that will push the masses forward. Okay, so all in all, guys, x cannot be negative 11,66. Therefore, we have to conclude that the only value of x is actually x is equal to negative 0,34. Okay. Shone? Sharp. Okay, let's move then to the very next, the last correction problem that you guys wanted us to do. So here we are. The square root of 2x minus 1. This one you need to listen to, please. Minus the square root of x minus 1 is equal to 1. When I was marking some of you, I observed that some of you thought that if you look at the left-hand side, the surd has been isolated. And I was like, Aibo guys, okay, if you're saying so, okay, let's just say, okay, the surd has been isolated. How many terms do you see on your left? I'm sure you can see there are 2 terms on your left-hand side, right? And they are both surds. So if you are going to say, let us square both sides, all right? You know, I saw people do this. This is not allowed, good people, okay? We can't say this is squaring both sides because the surd has been isolated. No, all right? No can do. Okay, I think we looked at a situation sort of similar where we square independent terms on the left or on the right. We don't do that, okay? Because, yeah, that would not be actually squaring both sides for a single term. There are 2 terms on the left. All right, so if we were going to square truly both sides, it would mean we'd have to square in this sense. We would treat this as a binomial, but oh my goodness, how it would drag if we were to do that. So what we then do is we actually isolate one of the surds on the left, okay, and create a binomial for the other surd on the right. So we can do this, guys, and this is very much acceptable. Okay, we take the square root of 2x minus 1 and isolate it alone, and then 1 is joined by the square root of x minus 1 on the right hand side. Okay, this surd, is it isolated? Yes. Okay, and even though there's another surd and there's another term, that is fine. At least we have isolated one of the surds. Okay, and basically what we are going to do, we are going to work this out until we can actually get rid of the surd entirely, and that will happen. So let's first start out by isolating one of the surds and just allowing that there be two terms on your right with 1 plus the square root of x minus 1. Now guys, we can square both sides. Voila, and look at me, square the right hand side. Please, this is a binomial. You square the binomial. Are you with me? Like this. You square the entire two terms binomial and then you square it. And you know what this means. When you square and there's an addition and a subtraction sign in between, it means you will open two brackets and you will FOIL the right hand side. This side, very simple. We get 2x minus 1. Happy? I hope we are, guys. I hope we are. This side, let us write out what basically we mean so that it can actually make practical sense for us as we work it out. Hopefully you guys understand why it is I'm opening two brackets of 1 plus x minus 1 in the square root. Right? Now, let's FOIL this. 1 times 1 is 1. We have this 2x minus 1. It's just going to wait for us to resolve what's in the two binomial brackets. So we FOIL this. 1 times 1, 1. 1 times square root of x minus 1 is plus square root of x minus 1. And then again, square root of x minus 1 times 1 is plus another square root of x minus 1. And then square root of x minus 1 times another square root of x minus 1. That means the square root and the square root, they cancel each other. We are left with, on the left, x minus 1. Okay, x minus this square root of x minus 1 times this square root of x minus 1. Remember, the bases are the same. It just means this square root and this square root will actually cancel. All right, and we'll be left with x minus 1. Okay, then let's continue. This is 1 plus square root of x minus 1 plus square root of x minus 1 means we have 2 square roots of x minus 1 plus x minus 1. I think you guys can see what's happening here. We're going to transpose everything that is not having a square root here. Okay, can I just get an indication that we are all on the same page as far as the right hand side? Do we understand what just happened? We said 1 times 1 is 1. Then we said 1 times square root of x minus 1 is square root of x minus 1. Square root of x minus 1 times 1 is another square root of x minus 1. And then square root of x minus 1 times the square root of x minus 1. Remember, when bases are the same, you multiply, you keep the base. But then the exponent, this is like having to the power half. A half plus a half gives you 1. That's why you have x minus 1 to the power 1. In other words, the square root and the square root, they basically, in essence, read each other. And we are left with 1. So there it is, guys. X minus 1. Okay? And then when we add those other like terms, we need to isolate still. So we isolate the square root the second time round. Yabo, we isolated first, now we had to isolate again. What's the whole intention of doing this? We want to get rid of the square root. Okay? We want to get rid of the square root. So let's go. 2x minus 1, let's transpose all the other terms. 1 over negative 1. This plus x over negative x. This negative 1 over plus 1. We are left with what on the right? 2 into x minus 1. Let's say we're getting very close. Ne? Let's add these like terms. 2x minus x is x. Minus 1 is negative 2. And then negative 2 plus 1 is negative 1. Square root has been isolated. So what do we do again? We square both sides. Do you see, people, but there's work to be done here. We are squaring both sides until we have nothing to square both sides. Isolate the third until we can get the equation to be solved. We get it into that form. All right, I need to get an indication. I don't want to move on too quickly at this point. Yeah, Sban. Yeah. This is one of those set equations. That's a challenge question. If you remember yesterday, what I did, I put a little asterisk or a star next to 7 to just indicate that there's a level of difficulty that's there, but it's not like that level of difficulty is so difficult that it cannot be done. It just means there's just a bit more that we need to apply to the question in order to be able to get to the solution. All right, but in all practicality, there's nothing in this thing. Okay, I know it is. It has to be too much work. Who are you? You are grade 11s and 12s, Sban. That have to understand too much work. Square, 4 into x minus 1. Open 2 brackets of x minus 1. By now you should know. I'm just going to go ahead and get straight to it. If you open 2 brackets of x minus 1, you get x squared minus x plus 1. So there it is. It's x squared minus 2x plus 1. Getting straight to the point, guys. Getting very straight to the point. Then we have 4x minus 4 because we distribute here. This side we have x squared minus 2x plus 1. Standard form. How does standard form look like? X squared minus 2x, we get the 4x over negative 4x plus 1, we get the negative 4 over plus 4 is equal to 0. I get then from here, people, all roads lead to success. Standard form. Then factorize. We know when we factorize, factors of 5, constant is positive, same signs according to the mother, signs are supposed to be negative, factors of 5 and 1. Our roots, x is equal to 5 or x is equal to 1. Check. Take that 5, substitute it into this equation. 2 times 5 is 10. 10 minus 1 is 9. Square root of 9 is 3. Minus 5 minus 1 is 4. Square root of 4 is 2. 3 minus 2 is equal to 1. It works, this one. It works. 5 works. Let's check 1. 2 times 1 is 2. Minus 1 is 1. Square root of 1 is 1. Minus 1 minus 1 is 0. 1 minus 0 is 1. You guys got it, man. You guys got it, didn't you, eh? You could see even like, look at that, look at this. Comments already were coming in. Rigby is like both. Yeah, well, even before I got there. Hi guys, I think like I said, you guys are showing me that your time is up, guy. We we thank you, we appreciate you. You've been here, you've helped us, you've been working with us. You maths is a game person, whoever you are, wherever you live, whatever you do. But Tina, we've got this, man. We've got this. You've given us the wings to fly. You've given us the wings to fly. Tina, we will fly away and we will reach, insurmountable heights. And then after that, we will tell you of the great things that we are accomplishing. So thank you, guys. That was that. Third equations, done and dusted. Okay. So today, I'm going to do this thing. Actually, there's something. I'm gonna do this thing. Something that we call quadratic inequalities. Hey, Mamela, please, Mamela, listen. Leicester. Right? Okay, so we are looking at quadratic inequalities. In grade 10, you guys did linear inequalities. Do you still remember these, guys? Grade 10. Solve the following inequality. Even when you guys wrote the baseline test, right? There were inequalities there. You still remember the baseline test? Balza is like, this is my favorite. Are you in grade 11? Balza okanye what agwan? Are you currently in grade 11, or maybe you are done with high school and you're just having reminiscent moments? Or you are in grade 12? Oh, your favorite. How nice. Alright, I get grade 12. You see, Balza Beauty. If you guys are lost, you can just contact Balza Beauty. Balza Beauty has volunteered to assist you if the need arises in any occasion. Isn't that so, Balza? Okay. Well, even though you don't like the topic loves you. Alright? Just remember that. It is obsessed with you. It desires to be one with you and to make its a permanent residence in your heart. So I don't care. We are going through turbulence at the moment. Turbulence. Hopefully it's back. Hopefully the network has restored its functionality in tip-top shape. Are we experiencing the return of network properly working now? Can we just confirm that in the comment section, please, so that I can proceed knowing that it has been restored. Okay, it is back. Amen. Hallelujah. Nothing brings me more joy. So you remember, I was just wanting to recap. Solve the following. So I wanted to recap linear inequalities. Here it is, guys. You remember when you guys solved linear inequalities, you were given an equation, x plus 1 greater than 0. Solve the following equality. Solve the following linear inequality. X plus 1 is greater than 0. So what do we do? Those people who said, this is my favorite, x plus 1 is greater than 0, solve the following inequality. Step number 1, what do we do? It's linear, this one. So I just want to see. Come on, beautiful people. X plus 1 is greater than 0. The first, what would we do with the linear inequality to solve? I've taught a lot, wise men. Too many. I've taught a lot. I taught exponents and surds. These people, they wrote even a test, just after January, the 1st. But we did exponents and surds. We are in the midst of quadratic equations now. We are in quadratic inequalities. We did the first few things that are there in quadratic equations. How to complete the square for quadratic expression and all these other things. Okay. Transpose, but you can find it on my YouTube channel. The things that I've done there have been uploaded, those live sessions, they are there on my YouTube channel. You can go to the grade 11 playlist and you can watch what you've missed at your own time, your own pace, and at your own love. Okay, yes, very good, guys. You guys are good. We transpose the constant term. So x is greater than negative 1. Okay. And since x is greater than -1, remember they would say to you, represent your answer on a number line. And then when you would go ahead, you would represent your answer on a number line. You would write the number -1. And then it says x greater than. This means x is bigger than -1. Remember that, guys? X is bigger than -1. Then what you would do is you would do open dot. Because x is greater, it means that the number -1 is not included in your answer. Greater than -1 means the arrow in this direction. The arrow is a solid line. Why? Because this means that all values after -1 are part of the values of x that will satisfy this inequality. So let's just think of practical numbers. Give me any number after -1. Any number. Aye, she's right. The network of mine is good. It's you guys now. It's not me. It's not me this time around, guys. Okay. Avo Motiba. Thank you, Ava. Sorry, DT Avo. Ava Motiba, you are giving me 0. And Dando's giving me 0, 1. Okay, let's just take 0 and 1 and 2. Let's just check with them. If we say 0 plus 1, we get the answer what on this side? 1. Is 1 greater than 0? Yes. Let's take 1 as well. 1 plus 1 gives us what? 2. Is 2 greater than 0? Yes. Let's take 2. 2 plus 1 is what? 3. Is 3 greater than 0? Yes. So that makes sense that all of the values of x, all of them that are after -1 will satisfy this inequality. So we say x is greater than -1. But you know what? We do not include -1. It's all the numbers that are greater or more than -1 that satisfy this inequality. Hence the answer. Okay. All right, no problem. Let's move. I like the fire, I like the energy that's here. Okay, here's another one. -2x less than 4. Solve the following linear inequality. Step number 1. Divide by -2. I love what you guys are saying. You said divide by -2, and that's the only thing you said to me. So I've done that. I'm waiting for something else. Then what? Excellence says then the answer is x is less than -2. Ndando says change the sign. Destiny says then the inequality changes. Pressure says divide by -2 and change the sign. The sign changes. X is less than -2. Change the sign and change the inequality sign. Good people, let us remember that the moment the coefficient is divided by a negative, this is the key thing. If this coefficient was a positive 2x and we divide it by 2, the inequality sign doesn't change. The minute you divide by a negative, immediately the inequality sign changes. I repeat, immediately. In that moment, you are dividing by -2. All right? Very important. Remember that -2 is multiplied to x. That is the relationship between -2 and x. We want to get rid of -2, so we apply what we call the multiplicative inverse. We divide the opposite operation of multiply. We divide by -2, but what we do on the left, we do on the right, and with an inequality, the inequality sign changes in that moment that you are showing division by -2. So the answer then is x is greater than -2. Did you see that? Are we listening to what I'm saying? Then, in your head, you are like, okay, if we represent the answer in a number line. Hey, let's very key this part. You see this part? This one. Your division by a negative leads to change of inequality sign. The direction changes. The direction. Division by a negative coefficient leads to a change in inequality sign. All right. And I want us to practically look at this, guys, because practically we want to say, okay, sure, the inequality sign changes, right? When we divide by a negative coefficient, supposedly the inequality sign changes. Let us go and check this thing. Remember now the answer will be x is greater than negative 2. In our number line, we have negative 2, key open dot, arrow in this direction, meaning all numbers greater than negative 2, they satisfy this equation. Let's check that. Remember, someone else would have just made the mistake and just kept the less than, and said, answer is x is less than negative 2. And they're like, yeah, we got the answer. Woo, woo. But then they are actually wrong. Why? Because they forgot to, when you divide by a negative, you must change the inequality sign's direction. So x is greater than negative 2, which means this. Let's think about numbers now that are greater than negative 2 and check them if they actually satisfy the original equation. Come on, give me one. Any number after or greater than negative 2. Just give me one or two numbers. Come on in the comment section. I know you people are always excited about numbers to give. Okay, Precious says 0. Let's check 0. Let's just check 0. And the Precious says 1 and the other one says negative 1. Let's check those three numbers. Let's just stick to those three numbers. Let's first check 0. Take 0 and substitute here. Negative 2 times 0. What do you get? We get 0. Is 0 less than 4? Amen. It is. I was man. It's not me, it's you, my friend. My network is perfect. It's good connection. It's good connection. 0 is less than 4, people. We agree, Mosne, that 0 is less than 4. So, truly, it's really these numbers after negative 2. Let's check another one. What about 1? Negative 2 times, because someone said 1 earlier, 1 earlier on. Negative 2 times 1. What's negative 2 times 1? We get negative 2. Is negative 2 less than 4? Is negative 2 less than 4? Yes, it is. It is. Okay? You can think of all these other numbers afterwards. 1, 2, 3, all of them. You can substitute, guys. You're going to always get something less than 4. So truly, there is merit in changing the inequality sign. Alright? There is merit in changing the inequality sign when we are dividing by a negative for our inequality. The inequality sign must change. Had we not changed it, we would have said x is less than negative 2. Think of all the numbers before or that are before negative 2. If you substitute them, they would have not satisfied the equation. Do you see, my good people, my good grade 11s, so I'm giving you these two examples just as a snack to begin this. I don't know, maybe a snack is not the proper term, but I know some people, they have nightmares with snack because of what their teachers do with snacks. Apparently, I heard yesterday someone was talking about a snack and all of that stuff. Let's look at the third. Let's look at a third example just to sort of wrap it up. You guys also did these ones. What do you call this? We call this a Righty, that's exactly it for the answer here. Yeah, well, we should use the numbers that are greater than -2. They are the numbers. For inequalities, you have a family of numbers that basically satisfy the inequality. It's not just a single. You have an interval of numbers. You know, a whole spectrum of numbers. Inequalities is all about identifying a spectrum of x values that satisfy the inequality. It's not a single value like when you solve an equation. An inequality will expose you to a spectrum of numbers, a variety. You know, it's a buffet of numbers to choose from, if you know what I mean. So I hope you understand. But it's within a certain boundary or region of numbers, you know. So that's it. So if you look at this one, I'm sure you also remember this one. It's called a compound inequality, and your objective was to isolate x in the middle. If it has a coefficient and it has a constant term, the whole objective was to isolate the x in the middle. So you have x plus 1. What do you do to the plus 1? Okay. Yes, she's right. Yes, she's right. You've got it, man. You understand. Okay. We subtract 1. We use the additive. They call it the additive inverse. You guys learned about the additive inverse in grade 8. You should have in grade 8, in grade 7. Additive inverse. The opposite operation for a certain constant term. Plus 1's additive inverse is -1. It's what basically eliminates that positive 1. But remember, if you subtract by 1, you have to subtract by 1 here, and you also need to subtract by 1. You subtract on the left, you subtract on the middle, you subtract on the right. Okay? For all sides. Amen. Then we get -4 less than x less than 4. Right? And remember, let's just put a little bit of a interesting turn off. Let's put a less than equal to for this inequality there. All right. Then if we were to represent this on a number line, small number, big number, then we say open, and then we say shaded. Why do we shade this side? Why do we open? Look, if there's a less than and no equal, it means open dot. It means the value is not included. Open dot means we do not include -4. Just like, for instance, here, open dot means there's no equal. It means we do not include -2 as one of the values that we must check. No. -2 is not included. Okay. Is it okay to only apply that on the right-hand side and the left-hand side only without applying it to the middle? Remember, we are consistently applying the additive inverse to the middle, left, right. Why? So that we can eliminate the positive constant, that is positive 1. All right? Yeah. If you don't apply it, then I'm guessing you would basically write a step where you just write the x isolated already in the middle. Okay? I mean, that's still applying it, but it's just that you're not writing that you are applying it. But if you just simply write x in the middle, and then all of a sudden you say -3 minus 1 and 5 minus 1, it just means you mentally applied the additive inverse. But practically speaking, the additive inverse must be applied to middle, left, right. Middle, left, right. If we had a coefficient, for instance, of 2 here, we would apply the additive inverse. Then after that, apply the multiplicative inverse. We would divide by that 2. Middle, left, right. You understand? So basically, we are always looking to see who is interfering and making it impossible for us to have x in the middle. So additive inverse eliminates the constant term. Multiplicative inverse will eliminate any coefficient that is preventing x to be alone. So if we had 2x, we would divide by 2 after applying the additive inverse. All right, so that is just something to note, okay, for the grade 10 inequality. Okay, it's in the question, right? You would be given the actual question. You have less than, equal. When it's there, obviously you continue with it. All right. All right. It's even maybe in this question, they could have said x plus 1 greater than or equal. All right. But it's just that this one I wrote it as greater than alone. All right. Yeah. So here, this one, I decided to just pose a question where we have less than and less than equal. The less than part means when we are ready to write, we've officially written the answer and we are representing on a number line. Remember, this without an equal sign means open dot, and this less than with an equal sign means shaded dot. The shaded dot just indicates that we include 4, and without the shaded, the open dot means we do not include negative 4. But where does the answer lie? It lies in between. In other words, x lies between negative 4 and 4, where 4 is included. This would be a representation of our answer on the number line. Okay. Okay, so I repeat once again. After we've solved, we get to this point. This is our inequality. What does this mean, guys? What does this mean? It means x is greater than negative 4. Now, I want to show you here what we mean by it. Let's just look at this side. When we say x is greater than negative 4, remember, this inequality sign is opening its mouth towards the x value. So we read it as x is greater than what? Than negative 4. So what does x is greater than negative 4 mean? It means x is more than this value, negative 4. It's more than. But, read this side, we say, but it's less than or equal to 4. So though x is more than negative 4, but it's also less than and equal to, it's less than and it's equal to 4. So that's why we say, if we summarize it, x lies between negative 4 and 4, where 4 is actually included. That's why x is in between. X lies between negative 4 and 4. So this line is a representation of all the values that will satisfy this particular inequalities. This line represents all the in-between values that will satisfy this inequality. But it also includes what? It includes our value positive 4 as well. That is the family of numbers that would satisfy this inequality. All the values after negative 4, everything you can think of, even decimal numbers, everything in between, everything up until 4 will satisfy this inequality. But the number negative 4, it won't, because it's not included as one of the answers because of the open and the less than. The less than means open. It means the negative 4 is not included, but 4 is included together with these many numbers that we can find in between. Are you with me, guys? What informs us to put equal sign? What informs us to put equal sign is the question, guys. The question itself had a less than sign and a less than and equal sign. That's what informed us having an answer with less than and equal to. Okay? And then the less than comes from this less than that we had this side. Okay? Keep them coming, guys. Seems like people have questions. Okay? Keep them coming. So graphically, we would represent the answer in this way. X lies between negative 4 and 4. All right. And sometimes they say to write the answer in interval notation. So then, open dot means open bracket. Shaded or closed dot means square bracket. Do you still remember these, guys? Aibo, Queen, you don't understand this sign. Ha! Queen, come here for a second. I want to play this game. Let's go, guys. I want you to tell me. Less than, equal to, more than. This, less than. This, equal. This, more than. Is a queen. Come here. I want you to tell me, am I going to choose less than, equal to, or more than? 3 with 4. Which one do I choose? Is it less than? Is 3 less than 4? Is it 3 equal to 4? Is 3 more than 4? Ah, Queen, look at you. Less than. Yeah. Isa, Queen. Isa, Queen. Isa. Come. Isa, come here. -3, -4. Less than, equal to, greater than. Which one? Boitumelo says greater than. Queen says more than. Botlana says more than. Okay, good. Yeah, I would have been very scared if you guys had said, because there's a tendency that people tend to think that, So these basically are the symbols that we use to utilize when we would identify numbers that are more than, numbers that are less than, numbers that are equal to. Okay, so all in all, okay, I am saying to you, okay, this -4 will be less than x, okay, and this x will be less than or equal to 4. If we practically read this out, we are saying, if we read this, we are saying x is greater than -4. Think about this practically. What are values greater than -4? Don't values that are greater than -4 lie this side? Yes, guys, they do. But then there's a but here. But x is less than or equal to 4. In other words, x is also less than this value, yet equal to this one. So when we talk about the family of numbers, we are talking about the family of numbers of x that lie between -4 and 4. But we do not include -4, because -4 is not included, okay, because we don't have an equal sign. Okay, it's from -4, where -4 is not included, to 4, where 4 is actually included. Okay, so those are the numbers. The numbers in between -4 and 4 would satisfy this inequality that we have at the top there. Okay, so this will be a representation of our answer in a number line. Then there's sometimes something that they say, represent your answer in interval notation. This is just another way of representing your answer. Okay, and what I said to you is that less than means open. It also means open bracket. Shaded dot is when we have a less than, an equal to, or greater than or equal to. We usually use a shaded dot, but it also means a square or closed bracket. So we would write the smallest value this side because it's not included, meaning open bracket, and then we would write the biggest value this side, which is +4, because it is included and it is part of the solution. So it's from -4, where -4 is not included, to +4, where 4 is included. We call this interval notation. This is inequality form. This is the representation of the answer in the number line, and this is what we call interval notation. Okay. My beautiful people, this is what you did in grade 10. Linear inequalities. You did linear inequalities, and it was just linear inequalities that you covered in grade 10. In grade 11, you do quadratic inequalities. You do what? Quadratic inequalities. And I'm actually not going to get into quadratic inequalities. There's this strong inclination and feeling that I have that I probably shouldn't venture into and do and cover a quadratic inequality. Get to the business of the day. Presh, no ways. We are not getting into the business of the day. I have this this feeling that is saying, let's not go into quadratic inequalities. Leave these people to learn quadratic inequalities when they get to their schools with their teachers. Their teachers will teach them quadratic inequalities. Where now you have done your part. Like, I don't know, it's almost as if like I am hearing a voice within a voice. It's saying, stop right here. Do not go to quadratic inequalities. They must learn those quadratic inequalities at school. Oh man, yeah, I think so too. No, thank you, people. I appreciate it. Thank you guys. Cannot even dare to say, don't let the devil take. Or look at standard. Don't let the devil take over. How do you know? But it's the devil. It cannot be. It cannot be. All right. So guys, let's do two examples of quadratic inequalities. I will suggest and show you a method, and then after that I will give you challenge problems to do, and then we'll call it that. Okay, we'll call it that. So quadratic inequalities, and I think I am going to write a method just on the side quickly, immediately, so that people can sort of see that here it is. So quadratic inequalities, guys, it's fine. You can out, it's no problem. Quadratic inequalities, very important with quadratic inequalities. We need to get our equation in what? In standard form. I think by now we are so sick and tired of a standard form, but we get our equation in standard form. We, number two, factorize. In the situation where we can factorize, we factorize. 3, we write down something that we call the critical values. The what? The critical values. Don't worry, Shizrati, it will be done. The critical values. All right? Critical values, which in other words are like the roots of the equation. The solutions of x, the actual quadratic, those are the critical values. We call them critical values. 4, we represent graphically the answer. And then 5, we write the actual solution. Yeah, I guess, and you think when you've gotten the critical values or the roots, the solutions, you have gotten them. But no, you actually learn that it is not the case. It is not the case. All right. Right. So this is basically the method. We get the equation into standard form, we factorize, we get the critical values, which are the roots of the equation. We represent those graphically, and then we write the actual solution of the inequality, which is quadratic. So let's look at an example very quickly, very smoothly. I know that I've been failing some people by not making sure I show up in the appropriate time. So here we have it. X squared minus x minus 6 is less than 0. What do you see here? I have an inequality, guys. I have an inequality. Let us put a spanner on the works here. Let me change it up a bit. Let's do the following. Okay, let's do this. Sorry. Now that I'm thinking about it. Okay, let's basically write this as our first example. You see the example? Negative x squared plus x plus 6 is greater than 0. So what's the first step? We need to get the equation in standard form. Is the equation in standard form? And the thing is, it's no. And I want to emphasize, our standard form here simply means that our a, the coefficient of the x squared term, must be positive. And I've been emphasizing this thing even in equations, the quadratic equations, that we ought to have the coefficient of x squared as a positive. So what are we going to do? as you've rightfully said, we are going to have to divide by a negative because the coefficient of x squared has a negative sign and we can't afford to have that. So what does that lead us? It leads us to a division by -1, which means we get x squared minus x minus 6. What happens to this guy? Greater than. Does he still stay as greater than? Remember, we divided by a -1. Thank you so much, Boyd. Thank you so much. Inequality sign changes. Inequality sign changes because we divided by a -1. Right? So step number 1, standard form has been achieved. Okay. All right. And remember, it is because of division. Because our variable with the highest exponent, we ended up having a situation where we divided by a negative so that we can achieve the coefficient of x squared being positive. We divide by that negative for all terms, please, in the equation. Means we divide by negative here, we get x squared. We divide by negative with our positive x, we get negative. We divide by negative here, we get -6. We divide 0 by negative, we still get 0. Step number 2. This here is our standard form. We can go ahead and factorize. All right? Because we can factorize.